Hi, this is Algebra 1, Module 4, Lesson 6, Practice Problems. We'll walk through some of these and help you get going with them. First, we're going to practice those equations and inequalities and solving them. So, the local amusement park sells memberships, summer memberships for $50 each. Normal admission to the park costs $25, and members admission costs 15. So if Darren wants to spend no more than $100 on trips to the amusement park this summer, how many visits can he make if he buys a membership with part of that money? So he's going to spend $50 plus $15 each time he goes. We'll do an X for that, right? Because even though they pay 50, that just means they get it's $10 cheaper each time they go. And it needs to cost him less than 100. Could it cost him equal? Yeah, it could. He could spend his 100. Um, so for here, we want to solve this. So I'm going to subtract 50 from each side. We're going to run out of room, this little space here. Minus 50. This one cancels. And that gives us 15x is less than or equal to 50. And when we go to solve that, we need to divide by 15. Divide by 15 on both sides. And so 50 divided by 15 is about 3.3. So x has to be less than or equal to 3.3. Now, can he take 3.3 visits? No. So it would say he would have to do, he can only go 3 visits if he buys the membership and then goes and only wants to pay over $100. Nope, I did that on the wrong line, didn't I? It's up here. X is less than or equal to 3.3, which means he can take 3 visits. Okay, so now how many visits can he make if he pays the normal admission instead? Well, if he just pays the normal admission, then we're looking at 25x, right? So 25 each time he goes, less than or equal to 100. So if we divide both sides by 25, x is less than or equal to 4 visits. So he can actually make 4 visits if he just pays normal rate, doesn't get the summer membership. If he increases his budget to 160, how many visits can he make as a member? So now we're going to go with this original equation and actually do a 160. So kind of running out of room. I'm going to go down to the bottom and do it down here. So 50 plus 15x less than or equal to, now he's got 160 to work with. So let's go ahead and subtract our 50 again. That leaves us with 15x less than or equal to 110. So this time 110 divided by 15. X is less than or equal to 7.3. So this time he can do 7 visits, right? So it's still less than, he can't go over the 7 visits. 7 minutes. Now we want to know what he can do as a non-member with 160. So if we do our 25x is less than or equal to 160 this time, divide by our 25, and x equals 160 divided by 25. So now 6.4. So he can only make 6 visits. So it actually, if he wants to spend 160, he could actually do more as a member. But if he only wants to spend 100, he can actually do more as a non-member. So that's where this is helpful to be able to solve some of these out. All right, 2. Jay took a math test with 20 questions. Each question is worth an equal number of points. Test is worth 100. So write an equation that can be used to calculate Jade's score based on the number of questions she got right. So we have, with 20 questions each, 20 questions, and each is worth an equal amount, then um, we know that there's basically 5 points per question, right? 100 divided by 20 equals 5 points each. Okay, so if it's 5 times how many got correct equals the score, and X equals number correct, right? So if you score 70 points to earn a grade of C minus, how many questions would Jade need to get right to get at least a C minus on the test? So we need 5X to be at least, so that's greater than or equal to, a 70. Well, if we divide both sides by 5, X needs to be greater than or equal to 70 divided by 5 is 14. So she needs to get at least 14 right. Okay, you want to score 83 points to earn a grade of B. Now what does she have to do to get a B? Well, same thing, 5X greater than or equal to, this time 83. So if we divide both sides by 5, X has to be greater than or equal to, this case, 17. So at least 17 correct. All right, suppose Jade got a score of 60% and then was allowed to retake the test. On the retake, she got all the questions right that she got right the first time. She also got half of the questions right that she got wrong the first time. What percent of the questions did Jade get right in total on the retake? Whew. All right. So if her 5X got her a 60%, right? 5 for each one she got right is 60%. Then X equals 60 divided by 5, which is 12. So she means that she got 12 correct. And if there's 20 total, that's 8 incorrect, right? And so if she got half of those right the next time, so that was originally. So for the retake, writing for me. So the retake, she got 12 plus half of that, which is 4. That's a total of 16 correct. So now we want to take this 16 and plug it in to our X. And so 5 times 16, oh, I shouldn't use an X in there, should I? Because that'll confuse us. 5 times 16 is an 80%. So the second time around, she got an 80%. All right, let's practicing those inequalities. Let's scroll down. Okay, so now we're going to solve these and justify our steps. So I'm just going to do a couple of these. This is review. So to start with, we need to get rid of that multiply. So the opposite of multiplying is dividing. So it's the division property. And those cancel, leaving X is greater than, because we have to flip the symbol, -7. All right, So I'm just going to go on this left-hand side and work through these. Um, 2x plus 4 is less than or equal to 10. Well, I need to add 4 to both sides, so that's an addition property of equality. Those cancel. 2x equals 14. To get rid of a times 2, I need to divide by 2. That's a division property. Those cancel. X equals 7. So that's, oh, not equals. Less than or equal to. And I didn't have any negatives involved, so I don't have to do anything else. And 7. So you can do the even ones on your own. So from here, I want to get rid of a divide by -3. So I need to times by -3 over 1. So that's a multiplication property. Those cancel. X, because I multiplied by a negative, I need to switch my sign. 10 times a -3 is -30 divided by 9. I can actually simplify that and divide both of those by 3. So x is less than -10 thirds. Okay, I said I'll leave the other side for you guys. Solve an inequality and graph the solution on the number line. So again, we're just going to keep drilling those, solving these inequalities. So it's a subtractate. So I want to, right on there, add 8 to both sides. So x is greater than -20 plus 8 is -12. So I want to go here to -12, do an open circle, and then it's greater than. So I want to go that direction. Here, x plus 11. So to get rid of that, I need to minus 11. Those cancel. X is greater than 13 minus 11 is 2. And it's an open circle. 1, 2. And x is greater than that. So I want to go that direction. Remember, open circle means everything but it. Next, solve each multi-step inequality. All right. So we'll go ahead and work through these. So it's a +3, working my way towards the x. I'm going to do -3 on both sides. 4x is less than -1 minus 3 is a -4. Divide by 4. Notice I'm dividing by the +4. So x is less than -1. We're here on 12. Let's go ahead and distribute so we can make this a little bit easier. 4 minus 6x is less than or equal to 4x plus 4x plus 6. Okay, so I have a -6x here. So I'm going to add 6x to both sides. These will cancel. That leaves me with 4. It's less than or equal to 4 plus 6 is 10x plus 6. Okay, I need to get rid of my plus 6. So I'm going to minus 6. 4 minus 6 is -2 is less than or equal to 10x. Now I need to get rid of my divide by times 10, divide by 10. So I'm going to put my x first. X is greater than or equal to a -1/5 when I simplify that one. Okay, 13. Want to distribute these out. So 5 times 4 is 20x plus 5 times 3 is 15. Greater than or equal to 9 times x is 9x. 9 times a -2 is a -18 minus x. I have 9x's minus 1x. So I really have 8x minus 18. And so let's go ahead and subtract this 8x from both sides. Those cancel, and I'm left with 12x plus 15. Oh, you know what? I'm running out of space over here. Let's put it on this other side. 12x plus 15 is greater than or equal to, and what do we have left over here? Negative 18. So negative 18, I need to get rid of my plus 15. So I'm going to minus 15. Those cancel. 12x is greater than or equal to, and that's a negative 33, isn't it? Okay. Now I'm going to divide my 12, get my x by itself. And so x is greater than or equal to, I'm just going to leave it as this fraction, 33 over 12s. All right, and 14. Oh, that one's kind of ugly. Let's see. Fractions always scare people. Let's go ahead and write this out. 2/3 x minus half of 4 is 2x minus a negative 2 times 1/2 of 1 is 1/2 greater than or equal to x plus 2x's minus 6. So make sure we do those symbols in there that we need to. All right. 2/3 x minus 2x. Well, minus 1 would be a negative third. Minus 2 would be a negative, well, you know what? Here, let's just go ahead and we're going to just move this over. So minus 2x, we're just going to add 2x to both sides. We're going to do an extra step in here. 2/3 x plus 1/2 is greater than or equal to x plus 2x plus 2x. That's 5x's minus 6. So now I can subtract 2/3 minus 2/3. That gets me 4 1/3 x minus 6 plus half over here. Okay, so I basically just got my whole numbers kind of together, and then I worried about my fraction. That makes it a little easier for me to follow. And here is a negative 6, so I want to plus 6 to both sides. So now I have 6.5 is greater than or equal to 4 1/3 x. So this kind of gets ugly in how you're doing it. Let's put them all in improper fractions. So this is 13 halves greater than or equal to. That's 13 thirds x. So now when I'm multiplying, I'm going to do this in a different color. I want to multiply by the reciprocal, 3 over 13. So these will cancel, leaving my x. And I don't have any negatives in here, right? So I'm still doing okay here with not needing to flip my sign. And if I go to this one, the 13s will cancel, leaving 3 over 2. So x is greater than or less than or equal to 3 halves. So that was a little bit of a messy one, but we got through it. All right, 15, 16, 17. Solve the following equation for C. I have kind of run out of room up there, so I'm going to go ahead and do it down here. So 15. We have F equals 9/5 C plus 32. So if you don't recognize this from science, this is the equation to go from Celsius to Fahrenheit. If you have a Celsius degree and you want to know what is that, this is the equation to do it. So first, let's get rid of our plus 32. So let's minus 32. So F minus 32 equals 9/5 C. Now we need to get rid of our 9/5. So we're going to times by 5/9. Those make those cancel. What I do to one side, I have to multiply. Ooh, what did that do? So now I need to multiply this by 5/9. So we'll just stick that in parentheses so that we know we have to multiply it both. So then our final answer then is C equals, I'm just going to switch it around, 5/9 parentheses F minus 32. And so that's what you do when you have Fahrenheit and want to convert to Celsius. All right, 16. Given V equals 1/3 pi r squared h, rewrite the formula to isolate the variable r. So 16, V equals 1/3 pi r squared h. Well, we need the r by itself. So let's get rid of everything. Um, let's go ahead and do the fraction first. So to get rid of a 1/3, we need to times by 3, right? So times 3. So we have 3v. Oh, wrong color. 3v equals pi r squared h. All right. So now let's get our r squared by itself, which means I can divide by both pi and h at the same time. Pi and h. So the h's cancels, the pi cancels. So I have 3v over pi h equals r squared. Now, how do I undo an r squared? Well, the square root, of course. So that means r equals, again, I'm just going to rearrange these, square root of 3v over pi h. So that is the volume of a cylinder, pyramid, a cone. There we go, cone. That's what I want to say. So if we have the volume in height and we want to know what the radius is of our cone, we can use this rearrangement to do that. All right, 17. This is a long one. The area formula for a regular polygon is A equals 1/2 P times little a. The variable little a represents the apothem and P represents the perimeter of the polygon. So solve the equation for A. Well, again, let's get rid of our fraction. So let's times 2 to get rid of our half there. So 2a equals P times a. And since we want the a by itself, we need to divide by P. Those cancel. So a equals 2 capital A over capital P. It was the simplest of them all. All right, couple more. 18. Y equals mx plus b is the equation of a line. Let's isolate b. Well, y equals, oh, let's not use our one. So y equals mx plus b. Ah, why does it do this to me? There we go. So it's plus b, so we can just minus mx from both sides. So b equals y minus mx. Step. The equation for a circumference of a circle C with radius r is C, circumference is 2 pi r. Solve it for r. All right. Well, C equals 2 pi r. They're all multiplied together. So to undo multiplication, we can just divide by both 2 pi. Those cancel. So r equals C. I ran out of space. Let's write this a little smaller. C over 2 pi. All right, 20. The equation for the area of a circle based on a diameter d is A equals pi times diameter squared divided by 4. Solve the equation to isolate the d squared, or just the d. All right, so let's try our blue for this one. So A equals pi d squared over 4. Well, we could, um, we can go ahead and divide by pi. Well, let's multiply by 4 to get rid of this 4. So times 4 times 4. So 4a equals pi d squared. So now I can divide by pi to get those to cancel. So I have 4a over pi equals d squared. How did I undo a square? Square root. So over here, d equals the square root of 4a divided by pi. Big finale. Let's do some graphing. Graph both lines on the same coordinate grid. Identify the point of intersection, then test the x and y values to make sure they work. So y equals 2x plus 5. So I know I can go to the plus 5. 1, 2, 3. I'm going to zoom this one in just a little bit more because these little graphs are small. All right. 1, 2, 3, 4, 5 right here. And so I have a dot here, and then I'm going to go up to, just go ahead and use our lines, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And I don't know if this is going to go up or down. So I'm going to go ahead and start here and go opposite, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. So I should have a straight line here. Okay, negative x plus y. Well, let's rearrange this so that it's a y equals. Instead of a minus x, let's plus x. So now I have y equals 1 plus x. Well, that means my starting point is at 1, and I'm going to go up 1 over 1 because my slope is positive 1. Whoa, whoa, whoa. I didn't do my line. Okay, so I'm going to go start at 1, and I said I'm going to go up 1 over 1. Okay, so that's kind of going away from my other line. So I need to go the other direction to make sure I cross. Did I go far enough? Oh, just barely. Okay, so what is my point of intersection? Right here is my point of intersection. So that is negative 1, 2, 3, 4. So that's a negative 4, comma, 1, 2, 3, negative 3. So now to check my points, what I'm going to do is I'm going to substitute them in to my original equation. So I'm going to do this one was in blue. So 2 times negative 4 instead of x plus 5, does it equal negative 3? Well, that's negative 8 plus 5. Yes, negative 8 plus 5 equals 3. So that one works. Now for my second one, it was negative x, so a negative negative 4 plus negative 3. Does that equal 1? Well, negative of a negative is positive, so 4 plus negative 3 does equal 1. So there was my check. All right, let's go to 22. 10 plus y equals 3x. Again, let's get this in y equals mx plus b form. So let's minus 10, minus 10 minus 10. So y equals 3x minus 10. So I can go down to this negative 10. Line again, negative 10. And my slope is up 3 over 1. Oh, go. Up to 3 over 1. Up to 3 over 1. Up to 3. Oops, lost track of where it's at. To 3 over 1. Just going to do one at a time here. 1, 2, 3 over 1. This is hard to control. And then we'll do 2, 3 over 1. 1. One more time. 1, 2, 3 over 1. Okay, I have a straight line. I have a straight line. So now let's try green. So our other one. So again, let's get the y by itself. Minus 2x minus 2x. Those cancel. Y equals 0 minus 2x. So then I want to start with 0, 0, 0. And if it's a minus 2x, it's down 2 over 1, down 2 over 1, down 2 over 1. Yay, we have a point of intersection. And so that one, do a little dot in red, is positive 2, comma 1, 2, 3, 4. So 2, comma negative 4. So now to check, I want to start with my blue one, 10 plus negative 4, my y up here, does that equal 3 times 2? Well, 10 plus negative 4 is 6, and that equals 3 times 2 is 6. So that one works. So over here, 2 times my x, which is 2, plus my y, negative 4, does that equal 0? Well, 2 times 2 is 4. 4 plus a negative 4 does equal 0. So that one worked too. Last one. Okay, start with blue. Instead of a plus x, I want to subtract x. I keep hitting. Goodness. Okay. Oh, I had a button up there. Minus x. Those cancel. So y equals 9 minus x. That means I need to start at a 9, which looks like it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one is 9. Almost did it wrong. Good thing I counted. Start at 9, and I'm going to go down 1 over 1 because it's a negative x. So I'm going to go across this diagonal right over here. Make sure I'm doing all my corners. All right. So this one over here, it's a minus x, but notice I have a negative y, which means I have to divide by negative 1 for everything. So that means y equals 7, positive 7 plus x. So that negative turns all those negatives positive when we divide. So for the green, I'm going to start with 7. So 1, 2, 3, 4, 5, 6, 7. Good. It should be 2 lower than that. And then I'm going to do a plus x. So it's a positive up 1 over 1. Okay, I see my point of intersection right there. And that is 1 comma 8. So 1 comma 8. And so just to check my work, it says 1 plus 8. Does that equal 9? Yes, 9 equals 9. Oh, I used the wrong color. This should have been in blue. Okay, and then my other one, x is 1 minus 8 minus my y should equal negative 7. Yes, negative 7 equals negative 7. So we have now just checked those and proved them. Thanks for joining us, and we'll see you next time.